Hi, Mike Askew here. When I was asked to take part in this Maths is More webinar about So What is Mathematics, I found myself thinking about things that had influenced me and my own thinking about mathematics, and Alan Bishop's work came to mind. Alan, writing in the 90s, looked at how mathematics was used in communities across the world and came up with what he described as 8 universals, reasons that people had to develop mathematics. These are not exhaustive, but I think they give a good sense of the range of the purposes of mathematics. Counting, of course, won't surprise you as one of his universals. Across the cultures he studied, people used mathematics to quantify things that could be counted, and of course measuring is the complement to that. We use counting for things that are discrete and measuring for things that are continuous, so I can count cows, but I have to measure the volume of moos. The next two were about space and being in space. So he identified that people used locating to locate themselves and locate the objects in space, and also design, that mathematics to actually help design the built environment and the design environment is something that was used across the cultures he looked at. The last two were slightly different to the first four. Playing might surprise you that he found playing to be something that was a universal use of mathematics across the cultures he studied. And also explaining that actually using mathematics to look at why things operate the way they do was also one of his universals. The first two of these, of course, lead to what we traditionally know as the number curriculum. The second two, locating and designing, are the basis of geometry. But the last two are slightly different from the first four in that whereas counting, measuring, locating and designing are all about how we engage with our environment, make sense of our environment and work on our environment, playing and explaining are much more about working together with other people. I can play on my own, but it's much more fun to play with someone else, and I can explain to others as well as explain to myself. Alan argues that mathematics comes out of these 8 universal human experiences and leads to what he calls this symbolic technology. Now, I think one of the problems we have with teaching mathematics sometimes is we start with the symbolic technology and then expect children to apply it. But actually, I think we might be better off thinking about how these universals operate and how we could start with these universal experiences and help children see where mathematics comes from that. I don't have time to talk about all of these, but I want to just briefly share some thoughts on 2 of them, measuring and explaining. If we take measuring as a big idea that cuts across separate strands of mathematics, we can begin to see how it could glue things together and give a sense of the connectedness of mathematics and maybe cut down the amount of load that children have to do in learning mathematics. So, for example, the quotitioning aspect of division is actually a form of measuring. I'm measuring out in all of those problems, measuring out my ribbon and my unit is 6 centimetre lengths. I'm measuring out biscuits and my unit is bags of 6. I'm measuring out pizzas and my unit is half a pizza. Thinking of division as measuring in that way, I think helps children realise that the answer to 12 pizzas, when you put half on each plate, is 24 halves. The 12 hasn't miraculously grown to become 24, but it's just been measured out into halves. And similarly, if I look at fractions, they were invented by mathematicians to give you a way of describing measures which are less than 1. So if 3 friends share 6 chocolate bars equally, then of course they're going to get 2 bars each. But without fractions, if they share 2 bars of chocolate, which they can do, at best all we can say is they get less than a bar each. But of course, the language of fractions helps us describe what that measure is as 2/3 of a bar. There's actually a whole curriculum that's been developed around measuring. It's based on the work of a Russian psychologist called Davidov. It's been developed in Russia and taken up in some parts of the world. And in particular, there's a project called Measure Up in Hawaii. And if you search on Measure Up on a search engine, you'll be able to find lots of information about this curriculum and how it operates. Basically, rather than starting with counting activities, children start with these measuring activities. You can see on the left there, they've got 2 jars of liquid. one labelled E, one labelled L, and they're using elastic bands to show how much more there is in the L jar than the E jar. And then they move very quickly into using abstract symbolic representations. So where we've got those two smaller bottles, K and Q, they can record things like K is greater than Q, and Q is less than K, and K minus some quantity J. We don't know what that quantity is, but there is some quantity J, which if I remove it from K, it's going to give me Q, and so on and so forth. And the evidence is that children have moved through this measuring curriculum, have a much deeper and richer understanding of fractions, and don't have a fear of algebra because they've been using these algebraic representations right from the beginning. Playing, I think, is also something that I'd like to see going all the way through mathematics. I'm not an early year specialist, but I was in a school once where I was working and asked to go and do some maths games in nursery, and I was playing some games one day, and at the end of the session, this boy came up to me and said, "I've got some invisible money." And I said, "Oh, can I have some?" And he gave me some of his invisible money, and he said, I've still got more than you," he said. I said, "Oh, really? How much have you got?" And this is the conversation. I'm in red and he's in the bold black. How much have you still got? He says 10, 60, 100. And I say, I've got 10, 60, 101. He says, I've got 10, 60, 151. Me, 10, 60, 152, and so on. And you can see he knows how to up the ante from 52 to 61, from up to 50 million, and so on. And we just played this. He was just taking such delight in challenging me and upping the ante every time, until he obviously kind of thought he'd had enough of this, and he pulled out his trump card and he said, "I've got finity." And I said, "Really? Can I beat finity?" And he said, "No, you can't do a trick for finity. It's the end of the numbers." And I just love the fact that here's a 4-year-old who's taking delight in playing with the idea of infinity. And if only we could have that joy, that delight of playing with numbers, of playing with mathematics all the way through the curriculum. Again, I think a lot more people might fall in love with it. Another writer I was thinking about was a writer called Lorty, who back in the 70s was writing about what he called the psychic rewards of teaching. And it got me wondering what I would think of were the psychic rewards of maths. And I just want to finally share some thoughts on that with you. I think there's a reward, a psychic reward, the joy of making a connection. I think when you see that a fraction is a way of actually recording the answer to a division when there's less than 1 as the answer, there's a delight, there's a joy in the way that those two seemingly separate pieces of mathematics come together. There's the satisfaction of tussling with a problem, that getting that sweet spot, being in the flow, as some people would describe it, where I've got a problem which I know I can get a solution to, but it's just beyond my reach at the moment. There's great satisfaction in that playing with it. The delight of seeing a shortcut. When I realised I was doing a problem a little while ago, it was a problem about an area within a rectangle, and I spent a long time trying to do it algebraically, and then took a break. And when I came back to it, I realised that there was a beautiful geometric way of solving the problem. And that delight of seeing that shortcut was what I would call a psychic reward. And again, the pleasure of sensing elegance. People who don't like mathematics are sometimes surprised when mathematicians talk about it being an elegant subject. But there is a beauty to mathematics. There is something lovely when you see that out of only 10 single digits, 0 to 9, we can create an infinite number of numbers, and the elegance of how the place value system works. There's real pleasure in getting a sense of that. And again, the awe of infinity, of playing with infinity, the awe of the infinitely large, the awe of the infinitely small. Those are things that I think can bring great joy and delight to the learning of mathematics. And so I hope you think about how you get joy from the mathematics and how you might bring some of that joy and delight into your teaching. Thanks for listening.